So, Esmita, would you like
Yeah,
to take it away?
sure. Yeah, I'm ready to get started whenever everyone else is. My name is Asmita. I am an assistant teaching professor at the University of Victoria in Victoria, British Columbia in Canada. And I also work with the JRMF Community Math Circle, which I know you've heard a bit about already. I do a lot of the back-end admin stuff, so I don't get to play with the kids as much anymore. So this is really fun for me to get to work with all of you and do a bit of presenting since I don't get to do as much of that in my life anymore. Today I'm going to be talking to you about Pentomino Puzzlers. I sometimes say Pentomino because my dad introduced me to these puzzles and he would mispronounce words sometimes. So if I say that, that's why, but I will try to remember to say Pentomino. Um, so yeah, I like talking about this. I see from the chat from those of you who have shared where you are that a lot of you are elementary school teachers, but I've seen at least one high school teacher as well. And I like this activity because like a lot of the activities we're doing today, it works for so many different age groups because it's really a puzzle about shapes and fitting things together. So I've got a few things for us to look at today, but the first thing I wanted to do is kind of talk about what is a polyomino. So a polyomino is a geometric shape. Oh yes, I have too many words at the beginning. Made by joining one or more equal squares side by side. For this talk, we're not going to consider rotations or reflections to be distinct. So I'm allowed to, if I can get to one shape from another by rotating a reflection, I'm going to call those the same shape. So if I have monominos, so just how many ways can I have one square side by side? I can see the chat. I've set up my screen with a lot of things. So if you want to put anything in the chat, how many ways can I have just one square side by side? If it feels like a trick question, it's a little bit because it is. Okay, I can just do this in one way. I'm just doing one square. Oh, sorry, trying to get my pen. This is the first time I'm giving this particular talk online, so I have to do all my tech things. Usually I have a blackboard behind me, so it might be a little bit rough. I can just have one way that I have one square, and I want them side by side, not corner to corner. So how many ways can I have two squares side by side?
Let me try. Four?
So if I'm having four different ways to have them side by side, I'm wanting rotations and reflections to be the same. So probably one of the ones that you're thinking of is this. I'm guessing that's one of the ones that you're thinking of. And maybe another one that you're thinking of is this one. But for the purposes of today, I'm going to say that those are the same thing because I can rotate one to get to the other. So for what we're talking about today, these are not going to be distinct. I'm just going to count this one once. So I think probably you were thinking of I have two and I can put them on all four sides. Those are all going to be counted as the same thing today. So thank you for being the brave one to give a suggestion. So we just got one domino. What about tromino? If I have three squares, how many ways could I fit three squares together where again, rotations and reflections are going to count as the same shape? Or you can give me one of the possible trominos if you can think of one.
Three.
So do you want to describe to me?
I'm thinking two as a base and one centered in the middle of those two, so as a pyramid.
Okay. So you're thinking of something like this.
Yeah.
Yeah, okay. I'm not going to allow those kinds of things today. I want them to be side by side. So this one is kind of side and it's touching one of the corners of here.
Then two, one
Yeah,
straight and one with a right angle.
great. Thank you. Yes, I have one straight. Thank you for giving me a suggestion. That means I have to be really careful about how I'm defining all of my rules. So I have two now. I can kind of put one straight and one with a right angle. Thank you so much. So if I look at four, then I'm not going to have us go through all of the ones, but we are going to go through them with five. I have five different pieces that I can have. If you've played Tetris before, there are 7 different Tetris pieces, and that's because these two both occur twice because I don't have, I have reflections as separate pieces in Tetris. But there are 5 different ways that I can build tetrominos. So I can put 4 squares together so that they're side by side. I have like every side is or I don't have them meeting so that they're meeting at any corners or anything like that. So that's when I have tetrominoes with 4 squares. So I've got 1 and then 2 and then 5. And it turns out there's not too much of a pattern here. But we can kind of think about how many pentominoes there are. So a pentomino is specifically a polyomino using 5 squares, so penta meaning 5. So if I'm not taking reflections or rotations as being distinct, are there any guesses for how many I might have of pentominoes? And this can be a total guess of how many you'd like to. So feel free to either guess out loud or you can guess in the chat, just giving some kind of guess of how many I think there might be. So we had 5 for tetrominoes. So 5 when we had 4 squares. Any guess for how many we might have when we have 5 squares?
5.
5? Okay, I think we're gonna get more than if we have 5 for 4. So we can add lots of squares in lots of ways to those tetrominoes. So it is greater than 5. 120, that's a bit too big. Otherwise, we're gonna show that all the ones that I have are kind of are actually all the ones I have. And if there were 120, I would not be doing that with you. 25, that's getting closer. That's getting closer.
Your page wouldn't be big enough for 120.
That's true. That's true. 20, okay, we're still a little bit too high.
16.
15, 16, we're getting a lot closer. There are 12. Oh, my slides are not progressing. There we go. There we go. These are my 12 pentominoes. So if you have ever played Blockus, these pieces probably look pretty familiar to you. Blockus involves all the pieces of the game Blockus, involve all of the pentominoes, all the tetrominoes, all of the trominoes. So 3 domino, there's just 1 piece, and monomino, there is 1 piece as well. So if you've played with Blockus before, you've seen these. But how do I know that there's exactly 12? How can I be sure that there are 12 and I haven't missed any and I haven't double counted any? So we could draw a picture of every possible pentomino, just every way that I could fit 5 pieces together with my rules and cross out everything that was a rotation or a reflection, but that seems like it might be prone to error and a bit time consuming. So I'm going to show you an elegant way to show that we have all of them. And I really love this way because it's kind of a visual proof that I think that a lot of people can understand even if they're not used to doing proof. So the way that I'm going to do this, I'm going to create a couple definitions. So I'm going to say that the stem of a polyomino is a square or group of squares that's connected to at least 2 other squares in the, I should have said polyomino here. I'm going to give you an example in a moment. So any square in my polyomino that's connected to at least 2 or more, I'm going to call that a stem. And if it's connected to exactly 1 other square, I'm going to call that a leaf. So for example, in this tetromino, I am going to call this bit the stem because each of these squares touch at least 2 other squares. In this case, they each touch exactly 2 other squares. And I'm going to call these 2 squares the leaves because they touch exactly 1 other square. So again, a stem has to touch, anything that's a stem has to touch at least 2 other squares, and leaves touch exactly 1 other square. Okay, are there any questions about kind of what I'm calling stems and leaves? I'm going to have that definition on my next slide as well so that we have it with us as we keep going. Okay, let's keep going then. So I'm going to start us off with some different stems, and we're going to see what shapes we can make with 5 squares once I give a given stem. So there's my definition of stem and leaf again. So remember, stem is connected to at least 2 others squared. Leaf is connected to exactly 1 other. So here I've got my stem. It is just my monomino. So I've labeled this 1 so that as we're doing this, when I get more squares, it'll be easy for us to refer to it. So I need to have 5 squares total, and only 1 square is touching more than 1 piece. Everything else is touching exactly 1 other piece. So if I wanted to add squares here, I want to add things to my stem. I could add squares on either side. I have 4 squares to add, and I want to add them so that I'm only adding to my stem, and so that everything I've added only touches one other square. So that is going to give me this piece. I did give this one as an example just so you can kind of get an idea of what I'm trying to communicate. So I'm adding leaves to my stem so that my leaves are only touching in one place and they are touching something in the stem. So if I give another stem, I give the domino as my stem. Where could I add leaves? Now I have 5 squares total, so I've accounted for 2 of them. I need to place 3 leaves. Where are some places that I can place leaves? And you can say things like top 1, left 1, bottom 1, that kind of thing, so that we can communicate about where we're trying to start things off.
Top 2.
Top 2, okay. So the suggestion has been that I add 1 over here. Where else would you like me to add a square?
Right 2.
Right of 2, okay. And where else?
Down 2.
Okay.
No. Oh, yeah, down 2.
Okay, if I do down 2, then one thing you might notice is that this one looks an awful lot like the one that we found already. But another thing is that remember that I have a rule that a stem has to be connected to at least 2 other squares. And right now the square that has 1 in it is only attached to 1 other square. So I actually need to make sure that I attach things to both 1 and 2 to create a new polyomino. So where else, instead of adding to the bottom of 2, would you have like another place that I can put that square? I want to attach it to 1 somewhere on 1.
How about below number 1?
Sure, let's do below 1. There we go. I've got 1 shape. Maybe let's go with the suggestion I had before. I'm sorry that my squares are not very nice because I'm trying to draw on my screen while still talking to you. So could I have made with the start that I had before, is there somewhere else I could have added it to 1 to get a different shape?
Left to number 1.
Yeah, sure. Let's do left of number 1. Great. There's a different shape. Okay. That's all the ones I can get where I have added them to 2 in that way, but maybe let me add it to 2 in another way. This time I'll add 1 above and 1 below. Where else would you like me to add a square to make a new polyomino?
It could be right above 1 or below 1.
Sure, if I add it above 1, now I've kind of broken my rule again because I'm saying that all the squares that are connected to at least 2 squares are part of my stem. So now this would be part of my stem. So I actually don't have that as an option just because of my rules of how I'm naming this. We'll get that shape later on, don't worry. That is definitely one of my pentominoes, but under my rules that I'm trying to get all of them systematically, I can't get to that one yet. So where could I place it? If not above 1 or below 1, what other option do I have? 1
Is
left.
below
Great.
2, is the one below 2 still open?
The one below 2 is going to be
I mean,
a leaf. I can't add to that
the-
one yet.
on top of 2, is that still
Oh,
open?
yes, that is still there. Yes, thank you.
Okay,
I
so
colored it in for
there
other
we are.
reasons. Yeah.
So we have
So
it.
now I've got a third shape there. And this is all of the ones I can do by adding squares to that polyomino. So I've got my illustrations underneath all my nicer drawings. So there we go. We found 3 more. So there are 12 total. We've now found 4 of them. Let's do this again with 3. So now I'm looking to add 2 more leaves to this diagram. I need square 1, square 2, and square 3 to all be touching at least 2 other squares. And I'll notice that right now 1 is only touching 1 square and 3 is only touching 1 square, but 2 is already touching 2 squares. So I have 2 leaves left to add, and I need to add them to 1 and to 3 in order for that to be a step. So any suggestions of where I should add some squares? I have 2 squares to add.
Down 3.
Down 3, okay. Where else would you like the next one?
Can we do one to the left of one?
Sure, let's do one to the left of one. There we go. We've got one of our shapes. I think that we can find another one by doing below 3. So why don't we go back to that? What other place could I put this? My last one.
On top of one?
On top of one. Great. I can do that too. There we go. So those are the two shapes I can get by putting a square below 3. So then my other option would be, because I want to keep this as being my only stem, I can't put something above 3, but I can put something to the right of 3. Can I get any other shapes out of this by adding something to 1?
To the left of 1?
Okay, let's add it to the left of 1. So if I add it to the left of 1, this looks like it is a rotation and reflection of the one I've already got. So I've got the same shape in 2 different ways. That's okay. But I'm just going to count it once. We've already found that shape. Where else could I add?
Down 2. Above 1.
Okay, I heard a down 2 and I heard an above 1. So if we add it down 2, now 1 is a leaf and we don't want that. So I'm going to put it above 1 as per that suggestion. And there we go. I've got another shape. And those are really my only options, right? We kept trying to add them in other places and then it wouldn't follow my rules. So this is all of my shapes. We did it almost in the exact order I had it drawn on here. And there we go. So now we've got 7 shapes out of the 12 that are possible. Okay, let's keep going. So now I'm going to start with this tromino. I'll use the 1, 2, 3 here, and I want to add some squares to this one. Just like last time, I need to make sure that square 1, square 2, and square 3 are all connected to at least 2 other squares. And 2 is already connected to 2 other squares, so I'm trying to add leaves to 1, 2, and 3. So where would you like me, or sorry, to 1 and 3 in particular, because 2 is already.
Make a U by putting 1 on top of the 1 and 1 on top of the 3.
Sure, there we go. I can make a little U shape or a sideways C shape by putting 1 on top of 1 and 1 on top of 3. Perfect. What other shape could I make?
Is it possible for top of 1 and then down of 3?
Yes, I can absolutely do that. Top of 1, down of 3. Now I have a kind of S shape. What else can I make?
How about 1 on top of 2?
Mm-hmm.
And below 1?
Yeah.
Sure. Okay. So if I do this one now, again, it's broken my rule because 3 is now on its own and 3 needs to touch 2 things. So I'm gonna, I think we actually made this shape already, so it's already in our list. So it is one of our pentominoes, but it doesn't quite follow the rule, but I'll keep that one below 1. And let's find another place where I can add something to 3 to get me another shape.
May we add a box to the right of 3?
We can add 1 to the right of 3. Perfect. There's another shape. And that one is distinct from the other ones that we've made. And there's actually one more I can make as well.
How about above 2?
So I don't want to put anything above 2 because I have 2 leaves left to put, and 1 and 3 need to touch 2 things.
Okay.
Yeah, we've covered all the ones that go above 2 already.
Well,
It's I'm sorry.
left of 1 and then down of 2.
Okay, left of 1, that sounds good. If we go below 2, now 3 is only touching 1 thing, and I want 3 to be touching at least 1 other thing. But I'm going to keep that 1 to the left of 1.
Put it next to 3.
Next to 3 on the right. Yeah, there we go. And those are all of the places that I can put it. If I try to place them in other places, either it won't follow my rule or it will be something I have already made. So I've got all of these ones And if you're keeping count, we had 7, now we have 4 more, we have 11. I told you there were 12. We're only missing 1. It was one that someone suggested before. I'm going to start with these 4 put together, and I can just add a square wherever I want to. And in this case, I wrote on the right of 2, and there we go. I've got all of my pentominoes. So I find this a nice little activity to like think about where I can bring the squares to follow my rules. And I've systematically found all possible ones.
I got it.
Yeah. So sometimes we use, I'm not going to use this too much, but sometimes because we might want to talk about certain pentominoes, they can be given names for the letters that they resemble. I'm not super used to referring to them by name, but I'm giving it to you in case you find it helpful. And I know that if you just kind of Google pentomino names, you'll see that, but you won't need to know to have the names too much for today. So the first activity I've got for you, I'll just talk through it and then show you a polypad, and then you'll have a chance to try it out in breakout rooms. We're going to try making 4x5 rectangles with these shapes. So here's an example of a way to make a 4x5 rectangle using 4 different pentominoes. So I've used 4 different shapes and fit them together into a 4x5 rectangle. And I've got a couple challenges for you. So one is to find at least 2 other ways to make a 4x5 rectangle. Again, using 4 different pentominoes, but I don't care which 4. We have 12 of them to choose from. You can find a solution where a pentomino piece doesn't touch the outside of the rectangle, so it doesn't touch the border on the outside. And another challenge I have for you is to find a solution so that the 4 pentominoes you use all touch at a single point. Someone pointed out to me that this is like there's a place which is the 4 corners of Utah, Colorado, Arizona, New Mexico, that you could all have that at one single point. So this is my challenge to you. You're going to have a chance to look at it in breakout rooms. But before that, I've created a polypad to use, and I want to show, oops, sorry. This is me having too many things to deal with on my screen at once. Okay, so just in case some people are not as familiar with polypad, I wanted to show it to you. I don't think you're seeing it right now though, are you? Are you seeing it?
Yes, we're seeing it.
Okay, perfect. It's just the green rectangle is not around my screen, so I wanted to make sure. Okay, so I've got the challenges written here. To use this polypad, all of the pieces you can just click and drag and they'll just keep generating as much as you want. And all of my pieces I can also rotate. So if I drag a piece, this black square, I can grab it and then I can rotate it and it'll snap into kind of my 90-degree turns. I can also press this flip button in order to flip a piece. And so I can just click and drag and try to fill these up. Again, I can keep dragging from here. There's just an infinite number of them sitting underneath. And yeah, I've drawn some 4x5 squares for you as well, so that you can play around with that. So I'm going to stop my share for the moment and share with you that polypad. And then I am going to make sure that everyone has a breakout room just so that we can explore. I'm going to see if I can get my notes back up here. One second. There we go. Okay, so I've got a few avenues to explore that I'm going to introduce you to. So a few different kinds of activities I can do with pentominoes. One of the ones that I have is making rectangles. I also have one on replicating pentominoes, one on monotiling, and one on building fences. So I'll explain a little bit about what all of these activities are. And then what I'm going to do is I'm going to open up some rooms where you can choose which activity you would like to do. So you're able to pick which one you'd like to do. I see that there's a hand there. Jessica, did you have a question?
I have a question. Yes, I do. Would I be able to access something similar to that Padlet source that the resource that you shared?
So I was going to put a list of, I've made polypads for all of these except for replicating, which Steve has some polypads for. And so what I'll try to do is I'll put together some resources so you can bring any of these polypads back to your classroom if you want to use them. As long as Steve lets me
follow
share.
up with lots of references afterwards.
Yeah.
Right.
I'll comment
Definitely.
that
I've made a bunch of polypads so we can use this.
I'll comment that I will put all of these on the teacher website. I will link them to the resources page. If you will really use them or pay you a stipend, I can even make and mail you copies of plastic pentominoes where you can use physical objects with your students.
Great, that's wonderful.
That would be a great resource.
Wonderful. Okay, so I'll introduce a few more activities that you can explore and that you can, of course, bring back to your students. So the first one that I have is on making rectangles. So for this activity, our goal is going to be to use all 12 pentominoes to make a single rectangle. So this is a good question for when students are learning multiplication, because we can think about which rectangles we can make in theory. I have 12 pentominoes, there's 5 squares on each, so 60 squares total. So really asking myself which rectangles can I make that have area 60, and thinking about which ones we can make in practice. Of course, I can't make a 1 by 60 rectangle because some of my pentominoes are 3 wide, so I can't make that rectangle in practice, but I can make it in theory. And then exploring how we can actually make those rectangles. So if you're interested in this activity of making big rectangles with all 12 polyominoes, we're going to have a room on that. I've got some polypads where you can get started, where I've given a few hints for ways to fill up the rectangles. There's often far more than just one way to make those rectangles. So that's one activity, making a single rectangle out of all 12 pentominoes. Another activity is replicating pentominoes, so doubling. So I'll explain what I mean by this. Suppose I take any one of my pentomino pieces and I'm going to imagine making a new piece that has dimension double the original. So I'm going to start with this like U or C-shaped pentomino, and I want to make one that's twice as big. How many pieces am I going to need to do that? The area is double what it was before. Or my size of my edges, sorry, is double what it was before. And what's going to happen to my area when I do that, and how many pieces would I need to fill in this big piece? Maybe it'll help if I add some grids so that we can see how many squares there are.
4 times as many.
Yeah, so I'm going to need 4 more pieces. And one way that I find it really easy to see that is if I think about like this one piece, it turned into 4 squares on the big one. And so that's my easy, quick way without having to actually know the area for figuring out that I would need 4 pieces. So I could try to make a larger version of the same shape using 4 pieces in total. So for replicating, some of the questions to consider are which ones can I make double the size? Which ones can I build to double out of different pieces? I can't do it to all of them. There's a couple that I can't do. And then constructing those doublings. So making those, taking 4 different pentomino pieces to create a shape that looks like a big single pentomino piece. And all of the pentominoes can be tripled. So I use 9 pentomino pieces to make something that has like 3 per side, or like each square, single square turns into 3 squares, and construct the tripling. So we've got one of our rooms will be on this replicating activity where you can try to make bigger versions of existing pieces. Another activity I have is monotiling with the pentominoes. So this time, instead of using multiple different pieces, I'm just going to use 1 piece. So I can really easily cover a plane with the I pentomino, which is just the straight line. But it's really boring, right? This is not a super interesting tiling pattern, but I could keep going forever in every direction. I could fill my wall or my table by covering with putting these pentomino pieces. I just realized the first one has 6 instead of 5. That was my bad yesterday when I was making this. All the others have 5. I just made a mistake in this first square. So that's a pretty boring way of doing a tiling. But I can look at what other shapes I can use to tile a plane. Maybe I have more interesting shapes and see how I can tile a plane, and if I can tile a plane, and if so, what does that tiling look like? And I can also think about tiling a rectangle with pentominoes. So can I use a single pentomino shape to tile a rectangle? So here's an example of using the P pentomino to tile a 5x4 rectangle. So I've got one rectangle, I'm trying to cover the whole rectangle using the same shape repeatedly. So this is one way that I could tile a 5x4 rectangle using the same shape over and over. And I guess the question here is, can I tile every rectangle with one side length 5 using any pentomino? I just stuck to side length 5 for today. One side is 5 and the other might be more. Are there some pieces that are impossible to tile with? Can we tile with the same shape in more than one way? So which tilings, which rectangles can I cover by tiling with no gaps and no overlaps with a single piece? So this is going to be the room on monotiling, is exploring that one where I'm using the same shape over and over. And another activity we'll have is pentomino fences. So I can use kind of in a different type of problem and look at making a fence out of my pentomino. So here's an example. Using all of 12 of my pentominos, making a fence of any shape around a field of any shape. So here my fence is really jagged and wiggly, and so is my inside field. That's the kind of thing that I'm looking for. I need to make my pentominos meet at an edge and not just at corners. I guess if I had just meeting at corners, my livestock could very easily jump out of my fence. So looking at the largest field I can make, so the largest area I can enclose by making a fence with all my pentominos. So here, visual I've got here is an example of a fence that encloses a field of area 43 units. It's not very efficient. You can probably make a way better fence than what I have right here, but it gives you an idea of the question. So this one is making a fence of any shape around a field of any shape, but I can also look a little bit more kind of restrict my problem a bit. So using all 12 pentominos, making a rectangular face around a fence around a field of any shape, and looking for the largest field you can make. So by rectangular fence, I mean the outside of my fence looks like a rectangle, but inside my fence, I could have any shape field. And then I could look at a fence of any shape around a rectangular field. So now I'm looking for the inside of my fence. The field inside is some kind of rectangle, and the outside can look like whatever I would like it to look like, and looking at the largest fence that I can make in that way. So are there any questions about any of these activities? I'll go back to the screen that has all 4 of them named. There we go. Should have done that more efficiently. Okay. What I'm going to do, I am going to create, I think I'll create 5 rooms, and I am going to just name them real quick. This is the boring back end part. So there's all of those rooms that you can do, and I guess what I'll do is I'll stick around in here. And if anyone is interested in just exploring that 4x5 rectangle activity from earlier more, then they can stick around with me in there and we can do that. And I'm going to make 2 different rooms for fences because I thought that one might end up being popular, because especially if some of you teach lower elementary, that would probably be a nice activity for your students about area. So I'm putting 2 I'm gonna put 2 people, or 2 different rooms for that. And if you see that one has several people in it, just go to the smaller one. I'm just adding my facilitators to the rooms that they should be in, and then I will open these up and you can choose where you want to go.
So here we have the same pentominos, but these pieces are fixed. And the rectangles are different shape. So do we have any suggestions on what to do? How do we explore that? And then unmute yourself. I mean, we are adults. We could talk over each other without problems. For example, I totally know what to put here. You see, there is like no way. There is only 5 pieces you could put here. So let me take it from here. So that one goes here. We cannot avoid it. Here we probably have to do that. Yeah. Please talk to me. um,
You can probably get the long teal and lay it across the top.
yes, probably that's the only way that I could deal it with that.
And then get the orange L shape and put it on the edge of the green.
Wait a second. This one?
Yes.
If I do that,
Oh, that's
we
too
only
long.
have 3.
Yeah, that's too long.
I have to like rotate it somehow.
No, that won't work. The purple T upside down
The green one.
can
Yes,
go
green
by the blue.
Green one. Yeah, green one.
Yeah, it will go that way.
Okay. So what do we have left? We have this. Did that work? Oh, this is working. Oh, now that is T.
For kicking us off. I like the idea of adding 4 number talks to our math and science lesson. Students that are shy or don't
The
like
orange one all the way to the end.
Orange one. To the
several
end,
things
okay.
are designed to again provide an entry and access point to our students, regardless of what level they are on.
Upside down. Oh, no.
Specific conceptual
No,
knowledge.
it's too
So
long.
appreciate you sharing that, Monica.
That is like voice not from our classroom, right? Okay, that is not good. None. Okay. Huh. We kind of stuck.
We have about 3
Remove that one.
Again, feel free to reflect and draw your reflections.
Flip. Okay. That is like, huh, not good. At what point we were choosing things? Could we do that? If you do flip, if you do this, well, we will have to have another of that. Not all things have to have a solution. I don't know if it has a solution. I did solve, you know what, I did solve this and that yesterday. just not so you kind of know that there are solutions for some things. But oh, look, it works. It just worked accidentally. Wow, look, we did well. It is actually very meditative to sit and put things together like that. Okay, this I need to erase my things, clear my drawings. Okay. Do we have any suggestions for this one? Like again, we see that some things are unavoidable. Like this one is unavoidable and that one is unavoidable. Not that one actually. It could be this. We don't know about this one. Clear my drawings. Okay, so here we cannot do anything. It is 1, 2, 3, 4, 5. So we will stop here. This is five pieces. And here we will have at least that. Here we will have at least that because things cannot. But then we are not sure what would, if you go here or here. Like it could be optional, right? So this one goes here. That is not optional.
The green L can go at the end, the other end. And then the blue M, I think can go on top if you turn it.
Here.
And then put the green, the other green. Oh, that won't work. No,
Oh,
that
we could flip it and it could go here actually. It might be okay. T probably could go here. But that would require this long thing to go here. It's too long, we cannot turn anything around. Right? So if you do this, this L-shaped would work here. Yeah. Wait. Do you guys see that okay?
yeah.
And I mean, this is one of the problems that we could just meditate over. It doesn't.
What if you move that blue, the blue W one over? Like, yes.
Okay. That's
Okay.
nice idea. I really like it.
And then,
This is not movable.
let's see, move the L over, that green L, move it.
Okay.
And let's see what's left.
Well, we could do this because we could do that. Right?
Slide the blue one down.
Yeah. But the cross, it doesn't fit anywhere now. I mean, the cross is like pretty awkward shape just to begin with.
What if you turn the L, put it back and put the L on top? Move that. No, leave that, no.
This is here, okay.
Yeah, and put the L on top. Now
On
flip
top,
it.
but flip.
Flip it and then turn the, yes.
Okay, let's try.
And then put the cross down, yes,
Okay,
and then
and
put
we
the
have
wiggly one
M.
up on top.
Very cool.
There you go.
Oh, cool. So I just need to flip
And
that.
then flip that one. There you go.
Okay, cool.
We
Thank
solved
you.
it.